Hello, everyone. This will be a short lecture on Aristotle and Galileo. You're going to glue the handout into your notebook and add some highlighting and annotations to that notebook assignment to receive a stamp. The first few questions here on the Go Formative, I'm going to discuss with you, as well as the other slides, to give you some ideas of what you can add to your notes. All right, so starting off, Aristotle, and he was several thousand years ago that he was around, and so his ideas are pretty old, but they speak to the way we thought about science and before, like in the early days, if you will. So Aristotle's classification of motion, he had two classifications: natural motion and violent motion. And so natural motion, by his definition, is essentially just anything that you would see naturally. In other words, in our world, on Earth, what we see with our eyes as humans. Of course, this doesn't take into account some factors that we now know exist, but this was what you can expect from, a deep thinker who was just simply basing his ideas on what he could observe. So, number one, what type of motion? What was the first type of motion that Aristotle classified? And that was natural motion. And that just simply means that everything kind of has its proper place and it will strive to get there. A synonym for strive would be try. So, any object that is not in its proper place will try to get into its proper place. An example: stones fall. So, meaning that the stone's proper place is on the ground. So, if a stone is thrown into the air, it will fall to the ground. That is its natural place. Puffs of smoke rise. Smoke's supposed to go up, so it does. And that's its natural place. That is not the actual reason for it, but that is the reason that Aristotle came up with when he was thinking about these things. The next slide here, we have additional examples of Aristotle's natural motion, as he described it. Things go straight up and down if they are on Earth. Things that are not on Earth are circular. An example would be the sun and the moon continually circle the Earth. And this is back when that was the viewpoint, that the sun went around the Earth, not the Earth goes around the sun. And so that's what was considered natural because that's what was observed. In other words, without a human intervention or without some sort of force, these things would happen on their own. Of course, we now know that the moon circles the Earth due to gravity. There actually is a force. It's not, it would not go around the Earth if there was no gravity. But at the time, that wasn't understood. The other type of motion that Aristotle classified was violent motion. And violent motion was described as any external push or pull on an object. For example, wind blows a ship, a person throws a rock, something like that. Then came Galileo like almost 2,000 years later. Galileo came on the scene and he was Italian. He actually ended up becoming imprisoned because of his views conflicted with what the church believed. And so he had to be kind of careful with some of his science because it upset the church. So anyway, Galileo demolished Aristotle's assertions in the 1500s. What he discovered is that objects that you've heard of the Leaning Tower of Pisa, most people have, and Galileo actually did experiments, and he said the objects of different weight fall to the ground at the same time if there's no air resistance. So his hypothesis was that if you have two objects of the exact same size, but one's heavier than the other, they will fall the same if there is no air resistance. This was later proven absolutely by the first astronauts to walk on the moon. There's a video clip that was in the video montage that I had you guys watch on Newton's laws, where they actually literally drop a hammer and a feather on the moon to see that they fall the same. There's also the giant missile silo that was turned into a large vacuum chamber. and you were able to watch a bowling ball fall the same as a feather. So if we don't have air resistance, everything falls the same. Particularly, Galileo was talking about if they have the same weight, they will fall the same with no air resistance. In fact, all objects would fall the same if there was no air resistance. A moving object needs no force to keep it moving in the absence of friction. So he came up with this hypothesis that a moving object does not require a force to keep moving. It's the existence of friction that causes objects to stop moving in everyday life. Galileo also defined a force as a push or a pull. So a force is a push or a pull. Inertia is a property of matter to resist changes in motion. Its amount depends on the amount of matter in the object or its mass. So if we want to measure the potential inertia of objects, we would want to know their mass to be able to determine that. Galileo performed some experiments, and it's kind of an interesting conclusion. So the first thing is balls rolling downward, down a slope, speed up. Okay, so if we go balls rolling downhill, speed up. Balls rolling uphill, slow down. So logically, if there's no slope, then there should be no change in speed, right? So a downward slope increases, an upward slope. So if downward is speed increase, upward is speed decrease, then it seems that no slope would mean no change in speed. And with this observation and analysis, he came to that conclusion that the ball doesn't come to rest due to its nature, but because of friction. The surface friction is what is causing the ball to change speed. If that was not a factor, there would be no change in speed. And it's kind of an interesting thought to come to that conclusion for the first time, to be the first person to really put that together. Here is a quick question to assess what we just discussed. The use of inclined planes for Galileo's experiments helped him to eliminate the acceleration of free fall, discover the concept of energy, discover the property called inertia, to discover the concept of momentum. So we've been discussing today inertia. That is the correct answer, C. You can also see at the next slide here, it gives a bit of an explanation. Inertia is a property of matter. It is not a reason for the behavior of matter. It is the Newton's law that gives us the reason for the behavior of matter. Okay. All right, that is it for this first section. You may go ahead and complete the GoFormative, submit it, and glue the handout into your notebook. It should be annotated and highlighted as appropriate. And that is it.